Hi, I'm Gerardo from AWS.
Hi, I'm Chris from Ateme, and this is my architecture.
Chris, I'm excited. So live video streaming. Can you tell me why did you build this platform?
Sure. So at Ateme, we are providing software for telcos and broadcasters. And basically what they want to achieve is doing live video streaming over the internet.
Okay, great. So it means that they have several video streams, and I presume you want to deliver that to users.
Yeah, exactly.
Okay.
So the streams are coming from, let's take an example of a football game. Mm-hmm. So it happens in the stadium, that the cameras are recording what's coming from the stadium. Mm-hmm. And we also have some, inside the trucks, we have some of our equipments that are sending the signals to AWS.
Great. And how do those streams get into the cloud?
So we have two ways of working. Some of the stadiums have connections with AWS Direct mm-hmm. Connect. Mm-hmm. And so we get the streams through Direct Connect. And otherwise, we also have some trucks that are sending over 5G mm-hmm. to the internet. Okay. So let's send it for this.
And I'm guessing that's radio and maybe satellite as well?
It can be satellite as well, yes.
Good. So, okay, once the data is in, what do you do here?
So once the data is in, it's just the network connection here. So we mm-hmm. need to get the stream into our encoder. That's what is doing the compression of the video signals. Okay.
So, and I'm guessing this is a Kubernetes pod, right?
Exactly. So what we are doing is everything is running on Kubernetes. So we mm-hmm. are going to have a decoupled architecture. Mm-hmm. And in the encoders, we are doing one channel per pod.
One channel per pod. And you have many of those channels. How many do you have?
Yeah, we have hundreds of channels.
Great. Yeah. So you're running hundreds of pods.
Yes.
Great. Okay. And how are you scaling this service?
So the scaling depends on the number of channels for the mm-hmm. encoding parts. Mm-hmm. So it depends on how many feeds we are getting. Okay. And that's it.
Oh, great. So it's dynamic. So
it's dynamic.
The more feeds you have, the more encoder pods are you going to have.
Exactly.
Great. So after the streams are encoded, what happens next?
So once the streams are encoded, they are pushed to a packager. Mm-hmm. So the packager is the component that is going to adapt the video streams to whatever the device of the end user is.
Great. How many versions of those are? How many formats?
In most cases, there are 2 or 3 formats. Okay. And then there are a lot of resolutions.
Okay, great. So I'm guessing that for each channel, you could have a couple dozen of this.
Yeah, exactly.
Great. So how many are we talking about? Thousands?
So here, yeah, we are talking probably about thousands. It really depends on how many subscribers are watching at the same time. Mm-hmm. So we are scaling based on the demand.
I get it. So this is scaling, the encoder scaling based on the live streams, and yes. This is scaling in how much they are consumed.
Yeah, exactly.
So this must be bigger, right? The packagers.
Yeah, it's bigger.
How much is it scaling to?
It's scaling to, let's say, the ratio basically is 1 to 10. So mm-hmm. It's probably thousands here, roughly.
Okay, wow. And how do you optimize? Because I'm guessing this is a lot of compute. So yeah. What are you using to make sure that you are keeping it cost controlled?
Yeah, so what we do is we're actually using CloudFront. So what happens is that we have the streams that are coming from here mm-hmm. and that they are reaching CloudFront. And CloudFront is doing the caching and the delivery for us. Mm-hmm. And actually CloudFront is pulling the encoders here, the packagers here.
Okay. And what about the instance choice? Do you tinker much with it?
Yes. So what we did is we did a lot of benchmarking on different instances, and we used the compute optimized instances.
Okay. And did you do some tests to see which one gave you the performance that you needed?
Yeah, exactly. So we did some tests based on our software. I guess it's not the same instance choice for everyone, but based on our software, it was the C instances are the best one for us.
Awesome. This is I'm impressed about the scale at which you're running this with hundreds of channels and all in a very somewhat simple architecture, right? So can you walk me through the load balancer and what are these supporting services?
Yeah, sure. Let's start with the load balancers. So the load balancers are actually the link to CloudFront, the source of CloudFront. Mm-hmm. And why do we use load balancer? It's because we have several, I mentioned, a couple of packagers, mm-hmm. and it helps redirecting to the right instance of packaging.
Okay. When the users are consuming the stream.
Yes, exactly.
Okay, and what about the supporting services?
Supporting services, it's just the backend. It's the backend of our application. So basically, it can be monitoring pods. Yeah. So that's something that doesn't scale as much as the packager or the encoder. It's quite a bit more stable.
Okay, so sort of supporting services for,
Exactly.
well, that's
For
what it
our
says.
own
For
application.
the application.
Yeah, exactly.
Awesome. Thank you very much, Chris. I am impressed with this architecture, and I love that you are delivering such a high spectrum of channels and formats to users with it.
Thank you for asking.
Merci beaucoup.